Hey AP, this video is about combustion reactions and calculations. So last year in chemistry, or the year before, we learned about combustion reactions as one of our 5 types of reactions. And in a combustion reaction, we have some hydrocarbon, CXHY, that gets burned. In order to burn something, we need to have oxygen present. Oxygen's a diatomic, so it's O2, are going to come together and then rearrange to make carbon dioxide and water. And those are always going to be the products. Most of the time, we looked at hydrocarbons that were just made up of carbons and hydrogens. However, sometimes we could run into the situation where we have a hydrocarbon that is CXHY and then also has oxygen in it. So just be aware that this can also be a combustion reaction because it's still burning and it still has the same products. Okay, but oxygen can also be in it. When my hydrocarbon burns, all of the carbon from my hydrocarbon becomes carbon inside of carbon dioxide, and all of the hydrogen inside my hydrocarbon becomes hydrogen inside of my water. So what we're going to end up having to do is experimentally determine through calculations the formula of my hydrocarbon by looking at the masses of carbon inside my carbon dioxide and hydrogen in my water that I can then measure after I do the reaction. So we're going to work through an example that does this. And on these, you're going to be asked to find both empirical and molecular formulas. Okay, and that's why we spent some time learning about those earlier this week and last week. So cumin, or cumini, is a compound containing only carbon and hydrogen that's used in the production of acetone and phenol in the chemical industry. Combustion of 476 milligrams of cumini produces some carbon dioxide and 42.8 milligrams of water. We're told the molar mass is between 115 and 125 grams per mole. Determine empirical and molecular formulas. Well, first thing we're going to do is write the formula for our reaction. We have some hydrocarbon, cumi, CXHY, because we don't know what they are, and it burns, makes oxygen, and from that, or consumes oxygen, we make carbon dioxide and water. From the question, it tells us that we have 476 milligrams. So I write that underneath. And produces some amount of carbon dioxide, and then it also produces 42.8 milligrams of water. Unlike our limiting reactant problems, or we'd just have one product or one reactant and 2 products, we can't use the law of conservation of mass to figure out this amount or this amount, because we have 2 unknowns, and we don't know how much oxygen we started with, and then our oxygens in both of these. So we can't just add and subtract. Instead, we're going to have to use stoichiometry to figure it out. Personally, using milligrams is not my favorite thing to do, but remember there's 1,000 milligrams in a gram. So to change these into grams, I would divide by 1,000. So 0.0476 grams, which means this is 0.0428 grams. If you wanted to leave it in milligrams, you can. Then you're also working in millimoles. I just don't think it's something that we want to deal with right now. So this tells me my initial sample amount and that I have made water and some amount of carbon dioxide. So I need to then figure out my empirical formula of my cumini, CXHY. So that means I need to figure out my grams of carbon and my grams of hydrogen. I need to figure out both of those. Well, I know that all of the hydrogen from my original formula has come out in my water. So I'm going to use stoichiometry to calculate, well, how much of my 0.0428 grams of water is hydrogen. So I'm take my 8 grams of water, and the molar mass of water is 18.02 grams per 1 mole of water. Inside of water, for every 1 mole of H2O, I have 2 moles of hydrogen. And this is just the atom hydrogen, not the diatomic. And for every 1 mole of hydrogen, it has a mass of 1.01 grams of hydrogen. So 0.0428 times 1 divided by 18.02 times 2 times 1.01. So you get 0.004798 grams of hydrogen. Okay. If my hydrocarbon here is made up of carbons and hydrogens, and I know my mass of hydrogen, that means everything else must be my carbon. So to figure out my mass of carbon, I'm going to take my total mass and subtract my mass of hydrogen, and that will leave me my mass of carbon. I wonder if you guys can hear the thunder. It's thundering. 0.0476 grams minus my mass of hydrogen, 0.004798 grams. So 0.0476 minus 0.004798. So that is my mass of carbon. 0.428 grams carbon. So now that I know the mass of each of the elements inside of my compound, I can now go about doing a regular empirical formula calculation. Grams to moles, divide by small, multiply till whole. So, dividing by molar mass. Hydrogen, again, dividing by molar mass. And these are in moles. Here's my smaller amount, so I'm going to divide both by that. I get 1.33 and 1. 0.33 is a third. So I'm going to multiply both of these by 3 to get whole numbers. So 1.33 times 3 is 4. Wow, it is really thundering. So that means that my empirical formula, 3 came from my carbon, so C3. 4 came from my hydrogen, so that's H4. So C3H4. I feel like that's blurry. That's better. Okay. So this is my empirical formula. So that's the first part. And molecular formula. So that's what I can do next. Now remember, a molecular formula is some multiplier bigger than the empirical formula. And to figure out our multiplier, we're going to take our molecular formula mass divided by our empirical formula mass, which gives us some multiplier number that we'll multiply our empirical formula by. Okay. Our molecular formula mass is given to us in the problem as somewhere between 115 and 125. I'm going to split the difference and say 120. So I'm going to have 120 on the top, and then I need to calculate my empirical formula of my empirical formula mass. So carbons and hydrogens, 3 carbons, 4 hydrogens. So 12.01 times 3 plus 4.04 gives me 40.07. basically 40. So that's my empirical formula mass. So that's going to go here. So 120 divided by 40 is 3. So 3 times my empirical formula, C3H4, gives me C9H12. And that is my molecular formula. Finally, it could ask, although this one doesn't, it could ask for us to write our reaction. So we'll finish with that. So our reaction would be C9H12 combustion, so plus O2, makes CO2, H2O, 9 carbons, I'm going to put a 9 here, 12 hydrogens, that makes 6. 9 times 2 gives me 18. Oh, the electricity just went out. It flashed. I hope this is still recording. 6 plus 6, 18 and 6 is 24. Divided by 2 gives me 12, so 12 oxygens. And that is how we can do a combustion calculation to figure out empirical and molecular formulas.